Today we're going to start Chapter 2-4, which is adding and subtracting rational expressions. Remember, rational expressions being fractions. We're on page 4 of our Chapter 2 notes. So we're going to start out with fractions that have the same denominator. We really like to have the same denominator because, as you know, when you add and subtract fractions, they have to have the same denominator. So if that's given to us, then we have less work to do. So what we're going to do is we're going to combine the like terms of the numerators. And we're going to copy over the denominator. And then if the result can be simplified in the end, then we're going to simplify it as our step 3. If we factor the numerator and denominator and then cancel common factors, then it will be totally simplified. So what does that mean? That means if you take a look at this fraction, you can see a 7b in each one of these fractions, so they have the same denominator. So all we have to do is say 9a minus a plus 3a. So 9a minus a is 8a, and 8a plus 3a is 11a. So we added the numerators and we kept the denominators as 7b, and you can't reduce that down at all, so that one's done. The next one, we have x minus 4 in both fractions. So all we have to do is say 4 minus x in the numerator. Can't combine those, they're not like terms. And in the denominator, we have x minus 4. And if you remember, if you have both of them being subtraction and they're in the reverse order, then they can cancel out to a -1. So the answer to this one is just -1. In the next one, x squared minus 36 is the common denominator. So we're just going to take x minus 6 is our numerator, and the denominator, just copy it over, x squared minus 36. Now this denominator is the difference of two perfect squares, so you can factor this into x plus 6 times x minus 6. Remember, always factor if you can, because then we can see that an x minus 6, if you want to put that in parentheses, you can. The x minus 6 on the top and bottom cancel out, and you put a 1 on the top, because the final answer is 1 over x plus 6. Don't just write the x plus 6 down as the answer, because that's in the denominator. In this example, we have a minus 2 squared as the common denominator. So we're just going to take 3a and subtract 6 from it. And then we just copy that denominator down as a minus 2 to the second power. Well, the next step we're going to take is, because 3a minus 6 has a GCF, let's take that 3 out. And let's factor that out, and you're going to be left with a minus 2. And if you remember what a minus 2 squared, it just means a minus 2 times a minus 2. Just multiply it by itself. And then one of these a minus 2's is going to cancel, just one of them. And you're going to be left with a 3 on the top and an a minus 2 on the bottom. That's the end of that problem. In this example, we have x squared plus 3x is the same denominator. So in the numerator, 2x squared minus x squared is 1x squared. Now you have to be careful, because this negative applies to both the x squared and the 9. Be really careful, because this becomes 2x squared minus x squared minus 9. This is where people make mistakes a lot when you have a subtraction here. And then we have x squared plus 3x that we're going to copy over. This numerator can be factored into x plus 3 times x minus 3, difference of two perfect squares. And in the denominator, we have a GCF. So we're going to write the GCF outside of the parentheses, and we're going to be left with x plus 3 after we divide out the x. The x plus 3 and the x plus 3 are the same, and we are left with x minus 3 on the top and an x on the bottom, and don't cancel those out, because this x is a term. And remember, terms don't cancel. So we are left with that answer. Whoops. Terms don't cancel. So that's nice when we have the same denominator, but oftentimes we have fractions that have different denominators. So we're going to try to find a least common denominator, and usually we have to factor each denominator first. if it's factorable at all. And then we're going to change this to be equivalent fractions with the same LCD. And then we're going to add and subtract like we did above. So in this example, we have a 4x and an 8x. Well, the least common denominator between a 4x and an 8x is an 8x, because if we multiply the top and bottom here by 2, 4x times 2 is 8x. So it's a lot of times I would like you to write out what the LCD is. This LCD is actually equal to 8x. So to get an 8x, like I said, we're going to multiply the top and bottom by 2. And what that gives us is 3 times 2, which is 6, 4x times 2, which is 8x, minus 3 over 8x. And now what we can do with the same denominators is we just subtract the numerators. 6 minus 3 is 3, and you keep the 8x. And that's the end of that because it can't simplify at all. In this example, we have a 3y here and a y here. If we multiply the top and bottom by y, what would be the common denominator between a 3y and a y? Well, this least common denominator is really equal to just 3y. So I'm going to multiply the top by 3 by just putting a 3 outside of the parentheses, and multiply the bottom by 3, and that will give me a 3y in both places. So whatever you do to the bottom, do to the top, multiplication-wise. So I'm just going to write this whole fraction over again, 4y plus 3 on the top and a 3y on the bottom. And now I'm going to subtract. Let's see, I think I'll make this all one great big fraction and keep that 3y. This is another way of doing this. So this minus 3 will give us a minus 3 times y, and this minus 3, this is like a negative 3 times 2, is just a negative 6. And all over that same common denominator of 3y. So now we can combine like terms. If you see CLT, it just means combine like terms. So we have a 4y minus a 3y. 4 minus 3 is 1. So we have a 1y. 3 minus 6 is a minus or a negative 3. And in the denominator we have a 3y. Those 3's don't cancel because this 3 is a term. So that's the end of that problem. So just be careful of a negative or a subtraction. Now this one is a really tricky denominator to figure out which one is the least common denominator. Well, we have 1x here, and we have 1x squared here. So if we multiply both of these by, or if we multiply this by an x, we can get up to an x squared here. And we have a y here, but we have a y squared here. So if we multiply this by y, we're going to have a y squared over here. So what we're really doing is we're going to try to find the biggest exponent, and we're going to make that part of our LCD. So this LCD, the biggest exponent between an x and an x squared is an x squared. The biggest exponent between the y squared and the y is a y squared. So there's our LCD, x squared, y squared. Well, how do you get x squared, y squared here? Well, think about it. We already have the y squared, so we don't have to do anything to the y's. But this x, if we multiply the top and bottom by x, x times x is x squared, and we will have an x squared, y squared here. So I'm going to distribute this x eventually. How do you get a y squared here? Well, if you multiply the top and bottom by the y times y is y squared. So here's the bottom and here's the top y. So y over y here and x over x here. So what does this turn into? X times x is x squared. X times negative y is negative xy. Over here, we are going to distribute the y through the parentheses. So y times x is a positive xy or yx. It doesn't matter what order you write them in. And y times y is y squared. So this is the distribution here, and then we can write all over the LCD that we found, x squared, y squared. So now what can we do with this fraction? Can it be simplified at all? Well, we have an xy negative here and an xy positive here. Negative xy plus xy, they equal 0. So what we're left with on the top is this x squared, this plus sign, and that y squared. So x squared plus y squared on the top. And in the bottom, we have an x squared times y squared, that LCD. They cannot cancel because it's a term. That plus sign means that's a term and that's a term. Terms do not cancel, and we're done with that problem. And over here in the last example on this page, well, this one is a little bit tricky because c minus d and c plus d don't have any common factors at all. So what you have to do in this case is you're going to have to put the two denominators together in multiplication, because you can't just create a c minus d or c plus d out of each one of those. So what we're going to do is we're going to call our LCD c minus d times c plus d. So write that over at the side. And how do we get the c minus d times c plus d in this denominator? Well, I'm going to surround that with parentheses, and I'm going to multiply the top and bottom by the missing c plus d. And so I'm going to, I guess there's room off to the side here to write the c plus d. So now you can see that I multiplied top and bottom by c plus d, and now this is the same as that LCD. Now if you look at this denominator, the c plus d, well, it doesn't have the c minus d, so I'm going to multiply the top and bottom by c minus d. Surround that with parentheses and multiply the bottom by c minus d. So now if you see, we got the same denominator here. And now we can just put these two together. We can just add up those numerators and keep the denominator as c plus d times c minus d. That's the common denominator. Well, what happens in the numerator? 1 times c plus d is c plus d. This subtraction really means it is a negative 1. This negative 1 times c minus d. Well, negative 1 times c is a negative c, and a negative 1 times a negative d gives you a positive d. This one is really, really tricky. And now what we have is we have like terms of c minus c. c minus c is 0, and d plus d is equal to 2d. And then the denominator just says c plus d times c minus d. And you don't have to do anything else to that. That's the end. This d can't cancel because we've got some terms down there. So that's tricky. You might want to rewind this and replay it so you really understand what's going on here. The next thing we're going to do is we're going to just take a look at a couple of other situations here. When you have an a minus b, I guess I'll just look at this first one here. When you have an a minus b and a b minus a, well, look at those things. They are almost the same. The only difference is they're in the opposite positions. This is a positive a, this is a negative a. This is a positive b, and this is a negative b. So if you ever have this situation where you have a binomial, they're both subtraction, what you can do is you can change that around to be a minus b, but whatever this is, you're going to change it to the opposite operation. So we're going to change this plus to a minus if we change this second to a minus b. You see how I've switched positions? I've made this from a negative a to a positive a. I've made this from a positive b to a negative b, which just means I had to change that positive sign to a negative sign, and now look, they're both a minus b's. So we'll get some practice with these kind of problems in class tomorrow. So what we have now is a squared. Instead of plus, we have minus. a squared minus b squared. And in the denominator, there's our common denominator of a minus b. These can't cancel because they're terms, but what can happen in the numerator is we have the difference of two perfect squares that we can factor. So let's factor a squared minus, if this had x squared minus 25 or x squared minus 4, you know how to factor that. It's the same thing when you have a squared minus b squared. It gets factored to a plus b times a minus b. That's the factoring. And in the denominator, you have a minus b. And if you want to surround it with parentheses, you can, because then they look exactly alike. The entire binomial can cancel, and the final answer here is a plus b. And like I said, we'll get some more practice in class on those. These are some tricky examples, some of them. But hopefully you took some good notes, and we'll talk to you again tomorrow in class, or whenever I see you again.